we're going to look at linear inequalities in one variable and also two variables, and we're going to focus on what is the difference between the two. So first of all, linear inequalities in one variable. So if we have a linear inequality in one variable, an example would be like this. So x is greater than 8. Okay, so what that means, if I have a balance here, it's an imbalance where the x is bigger than 8, so it's going to tip the balance over. So you think, what values of x will satisfy this inequality? Well, 9 will, 10, 8.1, lots of values here. Okay, I'll go dot. Maybe 1,000 will do this. So we have more than one value that actually satisfies this inequality. So to show this, we can't just list out every single number because it's impossible. There's infinite numbers. So the way we do this is we show it on a number line. So we show that we want 8, okay, but it's not including 8, so we show it with an open circle, and then we just show it as an arrow on the number line. So all the numbers on this side of 8 will satisfy this inequality, so that our solution can be expressed on a number line like this. And it's a one variable inequality, so we show it in one dimension along a line. Okay, so that's the idea behind a one variable inequality. The solution is one dimensional. Okay, so that's an important concept to remember, because we are going to use a two-dimensional graph to kind of analyze this. Now maybe we don't need it so much for our linear inequalities, but it is good to see what this looks like. So I'm going to graph my x minus 8, okay, and then my inequality becomes x minus 8 is greater than 0. Well, the 0 is my x-axis, and really what am I looking for? I'm looking for where this graph, slope of 1, y-intercept of -8, I'm looking for where this graph is above the x-axis, or bigger than 0. So it's going to be above the x-axis at 8, okay, not including 8 because it's equal to 0 there, and all these numbers this way. And again, notice I'm expressing, although I've drawn it in two dimensions as a graph, my solution is a one-dimensional inequality, so my solution must be along one dimension. It's along the number line. Okay, so this is an idea that we want to kind of get across. We do use a graph to solve a one variable inequality or a one-dimensional inequality. We have to make sure that we interpret the solution as a one-dimensional solution or along the number line. So the part of the graph that represents the solution to linear inequality, okay, is going to be the part above the x-axis. Okay, so that part, this part here above the x-axis, is the part that represents the solution part of this line. Okay, and we express the solution along the number line. And the boundary is going to be where it's equal to, where x is equal to 8. Okay, so the boundary is the equal to part, and from that boundary either going one-dimensionally to the right or one-dimensionally to the left on the number line. Okay, so then that lets us move to linear inequalities in two variables. Okay, so what is the difference between a two variable inequality and a one variable inequality? Well, two variables, we're going to start with x and y. Okay, so we have y equals 2x minus 4. So I'm going to graph this. There's my y-intercept at -4. I'm going to have a slope of 2. So if I just kind of draw my points in here, that's the slope of 2. Okay, and there is my line, y equals 2x minus 4. Okay, so if I consider the inequality y is bigger than 2x minus 4, now I have an inequality and I have a two variable system, so I have a two variable inequality. And then I need to ask myself, does the point 2, -1 satisfy this inequality? So 2, -1 is right here. Okay, and it's important to understand that it's below the blue line. Okay, maybe I'll highlight that as well. This is my blue line, y equals 2x minus 4. So that point is below the blue line. And if I test it in my inequality, I get -1 is greater than 2 times 2 minus 4. So I get -1 is greater than 0. That's not true. Okay? So this point is not part of the solution. Okay? It does not satisfy this two-variable inequality. This two-dimensional coordinate, xy coordinate, does not fit this inequality. So what coordinates then would? Okay, so what are some other coordinates that would fit this inequality? Well, let's test a couple here. And the easiest coordinate to test is going to be 0, 0. So if I test 0, 0, I get 0 is greater than 0 minus 4. Is 0 bigger than -4? Yeah, that works. Okay, so 0, 0 represents a solution. What about maybe a solution here? Okay, so that's 0, 5. Okay, so let's test 0, 5. Y is 0, y is 5 when x is 0, so 5 is bigger than -4. Yep, that works. What about this point here? Let's randomly select another point. X is -6, y is -2. So -6, -2, plug it into my inequality. -2 is bigger than 2 times -6 is -12, minus 4 is -16. So is -2 bigger than -16? Yeah, that works. So all three of these green points fit the inequality. In fact, if we interpret it this way, that y equals 2x minus 4 represents the boundary, or equals, the greater than or less than should indicate above or below that line. So if y is bigger than this line, then it should be all the y's above that line should work, and in fact they do. All the y's below the line will be less than the line, so that means that they won't fit this inequality, so they won't work, and that's true as well. So if we test any coordinate on this side, every coordinate on this side is not a solution. Okay? Whereas every coordinate that I test on this side of the line, okay, this is a solution. All those coordinates are solutions. So then what's happening is that for a two-dimensional, two-variable inequality, we have a two-dimensional solution, or area solution. Our solution is not on a line, but the solution is an area. So how many points are there considered? How many points that work? Well, there are infinite points that work. Okay, so there's infinite solution pairs of x and y. Okay, so how can we show all the other coordinates satisfy this inequality? We show the solution as an area. And I'm going to be clear, it's a two-dimensional area. Okay, so two variables, we need a 2D solution, or in other words, an area solution.